Alright, so now we are going to talk about doubly linked lists. So as you might imagine, doubly linked lists are a lot like linked lists, only they're doubly linked as opposed to singly linked, right? So that will be our file that we're working on, right? And this is why I like to create a node class. That means that the node here won't interfere with the node for the singly linked list, right? What does it mean for it to be a doubly linked list? Well, let's go ahead and draw it, right? We're still going to have ourselves our nodes. One node, a second node, a third node, right? That should be enough for now. But whereas the singly linked list, and now I'm going to be careful about where I draw my arrows, we had only a .next pointer, a pointer to the next node. In a doubly linked list, we also have a pointer to the previous node. Now this allows us to overcome one of the disadvantages of a singly linked list, which is that we can only travel in one direction in a singly linked list. But now that we have a backwards link, we can travel backwards. It's unnecessary for a linked list, but it's useful to have a way to go backwards. It allows you to manipulate things a bit easier. You might think that it's twice as complicated, but it's because there's twice as many moving parts. And it's really not, because as it turns out, having twice as many parts means that actually that it's a lot harder to drop the entire chain, to basically to accidentally remove a node from a list, right? You get a lot more flexibility in the way you want to move pointers around, and I think it's also an excellent example to brush up on more linked list concepts. The third type of linked list, which will go on, which will be covered by your homework, which is a circular linked list. That can be done either singly linked or doubly linked, and my homeworks are written on the assumption that basically you're doing them singly linked. Doubly linked lists are simply a good way to show you how they work. Alright, so they have twice as many things. Oh, and I suppose that one other thing I want to mention is that we will have, of course, be keeping track of the head, but this time we will also make sure that we are keeping track of a tail node, the last node in the list. So we'll go ahead and get on with that. Alright, so first things first, let's make ourselves a node class, so this will be an inner node class, private static class node E, right? And it will have, and just like our other node class, it will have an item. Let's see, let's make it private node E next, which will hold the memory location of the next node in the list, and a private node E previous, which we'll just simply call prev, to also make it 4 letters long. That will hold the location of the previous node in the list, right? And of course, for the head, the previous will be nothing, so that'll be null, and for the tail, the next will be null, whereas the previous will be the second to last item. Alright? So actually, we do get some code we can reuse here, which will be very useful, right? Because we're just manipulating previous and nexts, let's go ahead and view exit full no distraction mode. Let's go ahead and open up the linked list class, and what can we get back? Well, first let's actually, so we're going to be able to reuse a lot of our code here. So obviously, as I mentioned, we'll want to maintain a node E pointer, the head. So that's pretty much the same. Private int size, right? That's going to be the same. But we're also going to have a private node E tail. Constructor. Let's see. Select none. Boom. Doubly linked list. This dot head is equal to null, just to be explicit about it. This dot tail is equal to null. And this dot size is equal to 0. Okay, so we set those up just fine. Alright, so so what are the differences so far? Each node has a previous pointer, and each node has a And the doubly linked list not only will keep track of the head, but also the tail. We could keep track of the tail in the singly linked list, but I wanted this to be simpler the first time going through it. Now this is like going through it the second time. Now, fortunately for us, as I mentioned, we get to reuse a whole lot of our code. Specifically, I'm going to grab this fellow over here, the get node, right? Because as we saw, we use that a whole lot. We don't need to use that. It's going to try to import the other node. And we're saying we don't need to. We're going to use our node. So be aware of that if you're copying and pasting from your IDE. And the reason we can use this is because this doesn't this is agnostic, because we've coded up our node very, very similarly, except for the addition of a single field. We've got we can basically just use this code because this doesn't care that there's a previous as well, and we're not changing any of the pointers around. We're just simply going to the next item. So it makes sense to basically that we're just following this chain, right? And we can ignore the fact that there's these arrows pointing in the other direction, since we don't need to travel along those to find a node. All right. Oh, and we still need to complete the node class. So actually, we need the constructor, right? Public node e item, which takes in the item, and it will say this dot item is equal to the item. We're not going to have a previous and the next setup. Those are going to be set up to null. Okay. All right. So the get and the set, I'm not going to bother copying over. They're going to work exactly the same as they would. So really what makes the difference is the add and remove and how those interact. So those will be in the next video, since I like to chunk them up.